we recording? Yep, we are. All right. So awesome. Welcome to class today. It's September 8th. Happy Tuesday. This is a good reminder. Bigfoot believes in himself. So Mr. Ross's Bigfoot says, believe in yourself. You can do it. We have a 4-day week this week. So I'm confident that we'll all be focused and on task and very productive this week. Let me let in Miss Eddie. Should be good there. All right, so the daily agenda. We're still continuing what we did on Friday. We started, I believe it was called, let me get the name of it, Build and Find Area. And now we're going to continue with the assignment that was posted on Friday. That's called What Areas Can You Build? So if you have the booklet, good morning, Miss Eddie. If you have the book with you, then please open up and turn to, I believe it's page 6. If you have a packet, then please open up to 1.2 in your packet too and follow along, please. We're going to continue on with that lesson on multiples. Okay, that's part of our target over here. I'll read it back to you again. Find areas of different rectangles with a given side length. Okay, we've been working on that for the last week plus. And the second bullet, understand that the area of a rectangle is a multiple, that's a key word for this section, multiple of each of its side lengths. And then it says homework down here, but we're going over it in class today. It was put in your assignments on Teams, but I don't expect you to turn it in. Just please use it to take notes today, whether it's in your packet or in your booklet, whatever it is. You don't need to turn it in because we're going to cover it in class. Okay, any questions? Okay, I'll stop sharing that screen, move you over here, share this screen. Okay. So you should be able to see this what areas can you build worksheet on my screen. Camila, can you give me a thumbs up if you see that? All right, Camila says she sees it. So everyone else should be able to see it too. This is page, it says 4 in here, but I believe it's 6 in your workbook. But just look for this title, 1.2, what areas can you build? All right, to kind of launch us into this, we talked about multiples a little bit on Friday, but not in a lot of detail. Today we're going to kind of zero in on what a multiple is. But first and foremost, I want to ask this question. If I am thinking of a rectangle that is 2 tiles wide, what is a possible area of that rectangle? I'll even get the picture started. So if I was drawing, let me go full screen on here. If I was drawing, and this is 2 wide there, and I'm drawing a rectangle and it's coming down like this. Okay, don't know what the height is, how many rows we have, but if I have a rectangle that's 2 wide and then however many tiles down, what is a possible area? Camila, go for it.
2 times 2.
All right, so if we had 2 by 2, and then what is that area?
4. The area
awesome. Yeah, very good explanation, Camila. Thank you for that. Let's do another one. So we have 2 wide. Let's say it's a little bit longer. Okay. What could be a possible amount of rows that this rectangle has, and what would be its area? Malia?
5 and 2.
Okay, so let's say it's maybe 5 high. So 5 and 2, if we did 2 times 5, let's say, what's my area here?
10.
10. All right, awesome. And then let's do maybe one more. Let's do a 2 there, and let's go. Okay, bigger than 5. I know they look pretty similar, but 2 and something that's a little bit bigger than 5. Can you give me a number of rows, maybe Tania or Adelina, and then share with me the area? Oop, let me get back over here. What could be a possible number of rows, or how tall this rectangle could be? And then what would its area be if it's too wide and then had that amount of rows? Adelina?
I think it would be maybe 6 or 7. The rows would be
Okay.
6 or 7.
Let's go 7. I like 7. So if we're doing 2 by 7, okay, what's the area here?
17 plus 17 is 14. 7 plus
7.
14, not 17.
7 plus 7, 14.
Yep.
All right. Very good. Thank you, Adelina. This is what we kind of reviewed on Friday, right? This was what we did up here. We had 2 tiles wide. What's the area? 3 tiles wide. What's the area? And so on. You remember doing that? Okay. And we found some pattern here. So I'll rewrite maybe 2 columns, or yeah, 2 columns in width. We said if it's a 2 by 1, our area is just 2. If it's a 2 by 2, which we just did over here, our area is 4. If we did a 2 by 3, our area is 6. Do you guys see a pattern? Starting to see a pattern? Right, I see Eileen's hand. Do you want to share what that pattern is, Eileen?
I was gonna say, do we write it down?
Yes, if you have your workbook or the packet, then it might be a good idea to write it down. But I will say, hold off for maybe this stuff right here that we're doing, because we're going to switch in just a second. I'm going to erase this, and we're going to tackle the worksheet part of it. So you don't necessarily need to copy what I just did down, but I'll let you know when I want you to start filling out the worksheet with me. So Camila, do you see the pattern? You want to maybe share what that is?
I noticed the pattern is like counting by 2s.
Right. So if we were to do 2 times 4 and continue the pattern, it's 8. And if we were to keep going and on, it'd be 10 and 12 and 14, right? We had a name for this. We had skip counting, right? And that's when we add by a certain number each time. So 2, 4, 6, 8. We had a word for this. It was that keyword that I highlighted in the main screen. 8 is a blank of 2. 6 is a blank of 2. Do you remember what that blank is, what that word is? If not, it's fine. We really didn't cover it much. We're going to cover it more today. It's multiple. Do you remember hearing that word, multiple? I'll write it down. And a multiple is any number that we can skip count to and land on. So another way of thinking about it is 8 is a multiple of 2 because we can multiply something by 2 to get 8. Right? We can multiply 4 by it to get it. We could say that 12, if we're going to continue the pattern a little further down, 12 is a multiple of 2 because we can multiply something by 2 to get 12, which is 6. Okay? If you don't fully get it at this point, that's fine. We're going to go through this worksheet and maybe it'll make more sense for you. Okay? So I am going to erase all this work that we just did. The work that we are going to do now, I would recommend you write it down. You might not have a lot of room because you don't have this blank sheet to the right in your workbook. But when it comes to actually filling out this worksheet, I want you to follow along because we're going to go through it together. Okay. So let's look at this. What we're going to do in this worksheet here, 1.2, what areas can you build? We're going to think about areas that we could build if we only knew one side length of a rectangle. Okay, we're going to think about the possible areas that we can come up with knowing just one side length. Okay, so Elena here is building rectangles with a width of 3 units and an area of 30 square units or less. Okay, so we have options. It can be up to 30 square units for area, but not more than. Okay, so if we were to start, it says build the rectangles Lana could make and draw the rectangles on grid paper. Label the area and the side lengths of each rectangle. Okay. Any ideas on how we can make sure we hit every single rectangle that's possible up to 30 square units? Any ideas? Because we're going to draw rectangles that are 3 units wide. So up here we have 3 units, and then we need a certain, Katie, I think there you go. We have 3 units wide. That's okay, Katie. Malia, do you want to go for it?
10?
Okay, how'd you get 10?
Because 3 times 10 equals 30.
Very good thinking. I love it. So this is one possible rectangle. 3 by 10 equals 30. So what do you know about the possible rows now, Malia? Since you found kind of like a quick way of knowing what 30 square units could be, what's the limit? What's the range of numbers that we can have for these rows? Do you have an idea? If we're trying to stay under 30 now.
Like 5?
We could do 5 right here. 5 could work. Maybe let's test them out. What if we did 3 by 11?
Yeah.
What's our area there? Three times 11. If we were to skip count by 11 3 times.
55?
Not 55. It's 3 times 11. 5 times 11 would be 55. But if we skip count by 11, if we start at 11 and we add 11 to that, we would get
50?
Let's look at this right here. If we are skip counting 3 times, right, with 11, 3 times, the first time is just 11. If we add 11 to that, what do we get? 11 plus 11.
12. Wait, no. I did 11 plus 1.
Do you need some help?
23?
Close, you're 1 off.
22?
22, right? So that's if we skip count twice, but we need to skip count 3 times. So we need to add 11 more to this. Oops.
33?
33, right? But we need to stay underneath 30 square units, right? So based on this, if we're at 3 times 10 gives us 30, and 3 times 11 goes above that and gives us 33, I think we need to find all the side lengths with 3 for the width, but the other side lengths that are between 10 and 1, right? Because we need to stay less than 30. Okay, so let's quickly draw. Let's go 3 by 9. Let's power through this, all right? So if we had 3 there and 9 here, what is 3 times 9? And I might just stick with one person to help me through all of this. Malia, do you want to be my multiplication? You want to be my calculator? Okay, so for all of these, I'm going to go to you for it, okay? So 3 times 9. What is that? Malia?
27?
Yep, 27. Very good. Let's keep working on down. We have 3 times 8.
It is 40. Oh, I
So
know.
we 3 times 9 gave us 27. What's 3 less than 27? Because that's 3 times 8.
$24.
Yeah, 24. Very good. Let's go 3 times 7. Do you see a pattern here?
22.
30. Close.
21.
Yeah, 21. You see each time we're dropping in by 3. Okay, so I'm going to quickly go through these patterns then. So we have, I'm not going to draw rectangles anymore if that's okay. So we have 3 times 6 is the next rectangle. Do you know that one, Malia? Remember, there's a pattern we're doing. We're dropping by 3 each time.
18.
Yep. What about 3 times 5?
15.
15. Okay, 3 times 4?
11.
Close.
12.
12. And 3 times 3?
6. Oh, wait,
That's
no.
3 plus 3.
Yeah.
If you skip count by 3.
9.
9. And then 3 times 2?
6. No.
And 3 times 1?
3.
3, right? So if I were to write these out in order, which I will for B over here, what is the area of each rectangle you build? Well, we had 3. Oh, my light's going off. 6. Let me run around for a second. So we had 3, 6, then we went to 9, 12, 15, 18, 21, 20, that's an ugly 4, 24, 27, and 30. All right, so my question for you now, these were the areas of each rectangle that we built together. What do we notice about the area? Is there a pattern here? All right, Malia, do you want to answer it? What's the pattern here? What do we notice about the areas?
That it's like going 10, 9, 8, and all 3s.
So 10, 9, 8, and all 3s for what we're multiplying?
Mm-hmm.
Okay, excuse me. Very good. Yep, that's how we got the side lengths that we're using to multiply with a 3. When I write it like this here, and we can see all of the areas in order for each of these rectangles. Can someone tell me if there's a pattern here for what I wrote in B? When I went 3, 6, 9, 12, 15, 18. Is there a pattern? Camila?
The pattern is that it is counting by 3s.
It's adding by 3s?
Counting.
Counting by 3s? Okay. So we notice that we are skip counting by 3s then for each of these areas.
Okay.
All right, Katie, your mic keeps coming on and off. I'm going to mute you for a second because it's making some noise. So yeah, that's exactly right. What do we notice about the areas? Well, they're counting by 3s. They're skip counting by 3s. Every time, if we're working from this 3 by 1 to 3 by 2, 3 by 3 in that order, every time we add one more row, we add 3 more to the area. You see that? We add a row from 3 by 1 to 3 by 2, we gain 3 units in whole. When we go from 3 by 2 to 3 by 3, we go 3 more units in whole. So each of these areas are skip counting by 3. Okay. how can we use the word multiple for one of these numbers here that are listed for the area? Can someone use the word multiple in a sentence to describe one of these numbers? Camila, is your hand still up or you just dropped it?
I have for the question, like to use like a multiple for one of the numbers. I have an idea. Like,
go for it.
So like the 3 and 6, 3 times 6. I mean 3 times 2 equals 6.
Okay. So which one is a multiple of 3? You said 3 times 1 gives us 3. 3 times 2 gives us 6. 3 times 3 gives us 9. 3 by 4 gives us 12, and so on. So this resulting answer, this area here of 6, we can say is a multiple of 3 because we can multiply something by 3 to get 6. Right? We can build an area of 6 out of a rectangle with a side length of 3. Does that make sense?
Yeah.
So we'd say that 15 is a multiple of 3 because we can multiply 3 by 5 to get 15.
Oh, okay.
27 is a multiple of 3 because we can multiply 3 by 9 to get 27.
Okay.
Does that make sense, Camila?
Yep.
Okay, so let's look at problem number 2. Why is 28 square units not a possible area for a rectangle with a width of 3 units? So can someone explain that? Why is 28 square units not a possible area for a rectangle with a width of 3 units? Any ideas? Adelina? Why is 28 square units not a possible area for a rectangle with a width of 3?
Because if you skip count by 3s, I don't think 28 is in the skip count.
So 28 isn't on the list when we skip count by 3. All right. So if we were to write this with multiple in our sentence, is 28 a multiple or not a multiple of 3? Adelina, could you help us out there if you know? Is 28 a multiple of 3 or is it not a multiple of 3?
28 is not a multiple of 3.
So 28 is not, and I'll underline it, a multiple of 3. Because if we were to skip count by 3, we would not land on 28. See, we can even look at our work right up here. 3, 6, 9, all the way up. We land on 27, but not on 28. So therefore, 28 square units is not a possible area for a rectangle with a width of 3 because it's not a multiple of 3. Okay. I don't see a lot of cameras up right now, and that's okay, but I want to take thumbs up, sideways, down. How are we feeling about this? Can you show me, is this making sense? I'm beginning to know what a multiple is and how it relates to the original number of 3 or of 2. Okay, you can go sideways, you can go down if you're not feeling good. This is just my way to kind of see where we're at. So be honest. Okay. We got 2 more problems here. So remember when we were up at the top, I'll zoom out a little bit. It says Elena is building rectangles with a width of 3 units and an area of 30 square units or less, right? We went up to 30 square units, but we didn't go above it. Okay. Well, now problem 3 is asking if the area was larger than 30 square units, what are 2 other numbers that could be the area of a rectangle in square units with a width of 3? So if we had unlimited range of the amount of rows, I'll start drawing it right here. Like if we were 3 wide there and way down and looking for an area that's bigger than 30, what could be an example of an area that we could have? Adelina?
Huh?
You had your hand up. Are you able to answer it?
Oh, yeah. I gotta place that down. The area is 30 square units.
So we're looking for one that's larger than 30 square units. Because remember, in the first problem up here, I'll scroll up. We stopped at 30 square units. We said 30 square units or less. So these numbers here are all less than 30 except for 30 right here. Like we went up to it. But now we have unlimited numbers to work with. Okay. So what could be a possible area of a rectangle that's larger than 30 square units that has a width of 3?
3 times, let's see. 3 times maybe it's hard. Wait.
So how do we get 30? What's 3 times what gives us 30?
3 times 10 equals 30.
Right. 3 times 10 gives us 30, right? So if we know 3 times 10 gives us 30, we need 3 times something bigger than 10 to give us bigger than 30, right?
3 times 11.
There we go. That's an example. So 3 times 11 gives us what?
3 times 11. Let's see. Let me just.
If we were to skip count by 11, we have 11 plus 11.
33?
Yeah, 33 is the right answer. Nice work, Adelina. So that's an example of one that's bigger than 30, right? If we were to write this down, 33 is an example. Adelina, do you want to explain why?
33 is higher than 30 units.
It's higher than 30, so it's larger than 30. Okay, but why does it work? Why does it work for a width of 3 units?
If you count by 3s, keep counting till you're at 33. It is a number that you can actually skip count like 3s too.
Okay, so you can skip count by 3 to it. Therefore, so is it a multiple or is it not a multiple, Adelina?
It is a multiple.
So it is a multiple. All right, very good, Adelina. Quickly on the top of your head, what's another one that's just above 33 that we could use? Remember, there's a pattern here.
Could be 36.
Yeah, can you quickly explain why?
All right, 36, 33. We're at 33 right now. So if you skip count by 3, then you would get to 36.
Okay, Very good. So you can skip count by 3 to get to 36 as well. So therefore, 36 is or is not a multiple?
Is a multiple.
It is a multiple. All right, 36 is a multiple. All right, real quick, this last problem we're going to do before I kind of do a quick little quiz just to check for understanding. What is another area that is not possible for a rectangle with a width of 3 units? Explain your reasoning. So what's an example of an area that's not possible? All right, Malia, you want to go for it? Answer this question.
The area that cannot be possible is 3.
3. Well, is 3 a multiple of 3?
Oh, yeah.
So what's a multiple, or what's an area that we couldn't skip count to and land on with 3 as a width?
21.
Well, what can we multiply 3 by to get to 21? We did it right over here on the top right. It's actually still up. 3 times 7 is 21. So you're listing multiples. I'm looking for numbers that aren't multiples of 3. So what's an example of a number that's not a multiple of 3? Any ideas? If we go up to number 2 up here, remember it says, why is 28 square units not a possible area? And we said, well, 28 isn't on the list when we skip count by 3, and 28 is not a multiple of 3. So what's another number up here that we didn't land on? We landed on 3, we landed on 6, 9, 12, 15. Camila, do you want to share a possible area that couldn't be met by width of 3 units?
26.
Okay, and you want to explain your reasoning?
Because when you count by 3s, you go past 26.
All right, so 26, because when you skip count by 3s, you pass 26. So is it a multiple or is it not a multiple of 3?
Not a multiple.
So it is not, underline, not a multiple of 3. All right, very good, Camila. Quick question for you. Is 26 a multiple of 2?
No.
You don't think so? You do think so?
Yeah.
Okay, explain your reasoning.
Because when you go 2, 4, I don't get the question.
Okay, that's okay. I was just throwing an extra question in for you. So if we were to, let's go over to the side here. If we were, now we're looking at 2s, everybody. So we're moving away from this worksheet. We're looking at 2s. If we were to skip count by 2, okay, we said, well, the pattern is, well, yeah, we're counting by 2s each time. But another pattern that we see is, aren't these all even numbers? 2,
Yeah.
4, 6, 8, 10, 12. Yeah. So any even number is going to be a multiple of 2 because when we skip count by 2, we will always land on that next even number along the way. Okay, so that's a little tip or a trick at this point that we can maybe put to memory. But that's all I have for this worksheet. I do want to throw a couple more kind of practice questions at you to check for understanding, okay? So I want to hear from some new people too. I've heard a lot from Camila and Malia and Adelina, which is awesome. Thank you for participating. But let's get some new voices in here while we finish up the lesson, okay? Is 15 a multiple of 5? When you know the answer, go ahead and raise your hand on the computer. Is 15 a multiple of 5? Tania?
I think so because 15 is a 5.
Okay.
And
Keep going.
And if you multiply 5 by 15, it equals, well, how I think of it in my head, if I don't do multiply, I do a plus sign.
Uh-huh.
So 15 plus 5 is 20.
Okay. I like the way you started on that, where you said, I saw that 15 is a 5. Okay. And correct me if I'm wrong, but when you say that, I'm thinking that last digit, the ones digit. We look at that and we see a 5. Well, when we count by 5s, the ones digit is either a 5 or a 0, isn't it? 5. Then we go to 10, and that ones digit becomes a 0. Then we go to 15, and it's a 5 again. And then 0 for 20, 5 for 25, and it repeats that pattern, right? So I love the way you started, Tania, because that makes total sense. I see 15 has a 5 in the one spot, so it has to be a multiple of 5. Good job, Tania. Let's do one more here. Oh, my lights went off again. Is 7 a multiple of 4? And this is where we'll end. So when I get somebody's answer, is 7 a multiple of 4? We can head on out. Eileen?
I think it is a multiple.
Okay. Do you want to share your reasoning?
Because
What was our strategy?
skip count.
Yeah. So if you skip count by 4s, do we land on a 7? We do?
Wait, no.
If we were to go over here on the left side of the screen real fast before we end the lesson. We start at 4, and then we add 4 to it, and we get 8. We add 4 more, and we get 12. 4 more, we get 16, and on and on and on. Do we land on a 7, Eileen?
No.
No, we don't.
So it's not a multiple.
Yeah, it's not a multiple because we can't skip count to it. Or another way of thinking is we can't multiply something by this first number to get that number that we're searching for. Right? We can't multiply any whole number by 4 to get 7. Right? So that's kind of our test. We can skip count, or we can think, can I multiply something by the root number, that's 4, to get the number I'm searching for? All right. Okay. Good job today. We're going to get into factors tomorrow, which is very similar to multiples. So if you have a good understanding of what we're doing with multiples, you should be set for our lesson tomorrow on factors. So if you don't have any questions, you're free to go. This was the homework that was assigned Friday, but remember, it's not homework anymore because we just did it in class. I will post a new assignment that we'll probably go over in class again tomorrow. So you won't, as of right now, have homework for today or tomorrow. But as long as you're paying attention in class and following in your workbook or your packet or on Teams, then you are set. All right. So if you don't have any questions, you're free to go, run around, eat some lunch, take a break, and then I'll see you tomorrow. Okay. All right.
Bye.
Bye, everybody.
Bye, Mr. S.
Bye. Have a good evening.
See you tomorrow.